what do we mean by motion? Well, how would you tell us what the motion is? Change? Change in displacement. We don't know yet what displacement is. That's the next slide, I think, or after the next. So we can't use it yet. There is a more accurate term. Change in what? Position. Yes. We have an object positioned or placed somewhere, located somewhere. Change in the location, change in the position. That's what we call motion. However, we have to be very careful because if you look at this situation, three objects. Does this move? Does this move? Well, does this object change its position relative to this object? No. So if I ask you again, does this move? You should say, I don't know. Because motion is relative. You have to ask, relative to what? And in that case, if I ask you about this object, you can say, no, it doesn't move relative to this table, but this object actually being moved relative to this one. This object hasn't been moved relative to this one, but it has been moved relative to that one. So the most important thing about the motion is relative. People sometimes forget. In 99% of problems, it doesn't matter, but there is 1% of problems when it does matter. Usually, we make a natural assumption that everything is being watched relative to the ground. And that works practically for all our problems. Well, if it's not the case, usually you are told specifically relative to. Because right now, even we all are at rest relative to each other. We actually all are moving relative to what? For the sun, for example, for the moon, for other stars. So the motion is relative. And to describe this motion, we have to either at least keep in mind or even state specifically relative to which object in this particular situation this motion is being analyzed. Relative to the table, relative to the ground, relative to the bush, a tree, the plane, the river. If we want to describe the motion, because of change in the position, we want to assign a specific measurable value to that particular change. And to do that, all we need to do is measure the initial position, measure the final position, and in that case, the change is a position. In the position is just the difference between the final and initial positions. And this symbol, the triangle, which is actually what? Delta, it's a capital delta Greek letter, always stands for final minus initial. Final position minus initial position, final velocity minus initial velocity, final temperature minus initial temperature. This delta always stands for the change, and change is always final minus initial value. That's it. Well, in general, the motion could be happening in space. And space is three-dimensional. In general, we need three rulers to describe the position of an object. One usually we call x, y, z. The simplest motion is, of course, one-dimensional motion. And that's what we're going to talk about first. One-dimensional motion is the linear motion. Object is traveling along a straight line. So we look at that line, and that's what we call a trajectory, a sequence of positions. We place a ruler along that line, and we can read the actual position of that object at any time. And that's what we call the, well, x or yz coordinate. And when object is moving, that number is changing. And the difference between the final coordinate and initial, that's what we call displacement. In general, if we have three-dimensional motion, two-dimensional motion, that difference between final coordinates and initial coordinates. What is the distance? The distance is the length of the trajectory. So if I move it from here to here, that's going to be my displacement. I can read the number. The final is 60, the initial is 10. The displacement is 50, 60 minus 10. But the trajectory was, well, like that, let's say a half of a circle. So the distance traveled is not going to be 50. It's going to be the length of this line. So the length of the trajectory is the distance traveled. Sometimes displacement and distance are equal to each other, sometimes not. And to see that difference, it's very important to actually draw a picture which shows you very clearly the initial position, the final position, the trajectory. In that case, the risk of making a mistake is very small. Okay. If you look at this picture, this is a standard notation for the initial position, x naught, x0, x subscript 0, whatever you call it. This is the standard notation for the final position. These arrows represent what had been happening. Starting from here, this object was moved to the left, and then back to the right. And you know that in this direction, it's been traveled 3 kilometers, and in that direction, it's been traveled 5 kilometers. So what's the total distance traveled? 2 kilometers, I said the answer already. 5. The total distance is this plus this. But the displacement, and here we have to be careful, because in many textbooks, the same word is being used for different things. They call displacement. They may mean the actual displacement, which in this situation is -1, or they may mean the magnitude of the displacement. And magnitude is never negative. It's an absolute value of the displacement. And sometimes that even confuses people doing the homework. It happens. The problem tells you, find the displacement. I would say 9 times out of 10, they mean actual value. So in this situation, you would enter -1, and that would be correct. But sometimes the person who writes the problem forgets it and actually means magnitude. You enter -1 and it doesn't work. What do? Try 1. You have 6 trials for each part of each question. Or send an email to clarify the situation. It happens. Not very often, but it happens. All right, you move 4 meters west, and then 3 meters south. That's going to be my last question. So you have to solve this problem, and I will poll it. I will ask for the displacement. The distance is simple. 4 and 3 is 7. The total distance traveled equals 7 meters. So my question to you will be, what is the magnitude of the displacement traveled by this object. And this is an example of a situation when you have to draw a picture first. And that's your first step when you're solving a physics problem. East, west, north, south, 4 meters west, 3 meters south, 4, 3. That's your displacement. How do we call this specific figure? It's a specific triangle. It's a right triangle. And what do we know about right triangles? Pythagorean theorem. So it has to be 5.